No movie has ever made such a big impact to the VFX industry like the 1999 Matrix movie. It introduced us to bullet time slow motion, popularized wire-fu, and brought us the most iconic title transition ever. You see this digital rain effect and you know where it's from. The closest to this are the Marvel titles, but they are the same for every Marvel movie and are still fresh in our heads because Marvel movies are just recent releases. The Matrix, on the other hand, was released in 1999, that is 24 years ago. And the titles are still iconic. So let's remake these iconic titles using Blender and geometry nodes. Let's start with a plane. You can scale it as much as you want and raise it up a bit, just like that. Apply the scale and rotation. First, we're going to instance some points using distribute points, just like that. That's too many. Let's try one. If you hit play, nothing happens. Let's add a simulation zone. And we want to turn these into vertices because we want to extrude these vertices. We want to extrude the vertices. So if we do this, you can see they're being extruded, and you see that the frame rate drops really down because for each vertex that is extruded, another vertex is extruded later on another frame. So we only want to extrude just once for every vertex we have. So to do that, we can create a selection of the initial vertices we have, adding this here and just selecting all the vertices we have and using that selection in the selection here, and that will also be the extruded, that will create a top selection for the extruded vertices. Basically, this loop here ensures that we only extruding once for each vertex, and you can see the frame rate doesn't drop. Now I can remove the offset, use a set position, and we want this to go down. And make sure you have the top selection, and now everything that is extruded is going down. We want to introduce some randomness. So to do that, I'm going to add some randomness to the Z value using a random value. In the Z, we can use again a negative values. If we play back, yeah, we get some randomness. But we want these to look like rain, so we don't want this to stick up here. We want them to fall down as well in a random fashion. Let's repeat this step here. If we do this, you can see everything is going down. If we use this top selection, it's as if we are repeating this same step. So this offset will be added. Let me do it like this so that it's much easier to see. This offset will be added. It's being added to the extruding part instead of the top part. So to add it to the top part, we just have to invert our selection. So use the Boolean and use the not. But we also want it to be random. So what I can do is just use the same offset here. Maybe change it a bit, make it a bit slower, and you can see we get some results there. Or we can use the same offset here and just use a vector math to scale it up and make it a bit slower than the first offset to get, yeah, something like that. You can see how they are falling down. Now we want more particles to come in. So what I can do is use a join geometry here and join these vertices. To show that more particles are being added in and are not in the same position, we can use a time node, plug the frame into the seed. Now you can see we should be having new points. One thing we need to do is to have them extruded as well. We need to add them to the selection. So to do that, we can use a capture attribute. We want Boolean. Check that and then use this Boolean math with the operation of O, so that we can basically add these new points in. And you can see now we are adding new points. This is a lot of points, so we can start removing some after some time using an edge factor. So we can create a new value in the store name attribute, call it edge. And what it's going to be, let's just use a named attribute again. And basically what it does, it checks the previous value and adds 1 on each frame. basically capturing the edge. This should be 1. So, and from there we can delete any vertices whose edge is greater than, let's say 30, and we should start to see vertices disappearing at frame 30. From there, let's turn this into curves, mesh to curves, and curve to mesh, and let's just use a line curve for the profile. It can be negative 0.1 and positive 0.1 on the edge. So you can see how this looks. Okay, so they're dying earlier than I want, so let me use 50. Yeah, so they can die around there, and still we can use a set material so that we can start working on the material. I can create a new material, call this lines. So let's go to the shader. Let's capture some UVs or masks that we can use in the material. I'm going to use a store named attribute, and I want this to be length to capture the spline parameter, or the length of the spline. So I also want the width of this and this is also the factor. So if we go to the shader editor, we can bring in the attribute, and you can see that gives us the length. Bring my image, reference image here. Okay, you can see we have our gradients. You can just use an emission and a ramp to get the same colors. So, and also use some transparency. Since we are using Eevee here, I'll turn on bloom and alpha blend. I think I need to switch these up just like that, so you can see what we have. We can also use diffuse glossy because we don't need these strips to be emissive all the way. It can still have the same color. We need to blend this, so that the top part is reflective and the bottom part is emissive. Now if you look at this, the edges are a bit harsh, so I can use the width factor we created and just use our ramp, make it so that the edges are a bit more softer, and that way we can use our math node to just, I think it's multiply these two here. Now you can see now the edges are much softer than we had before. Now you can see we have that working. Now let's add the numbers. Let's add the numbers. So we can go back to geometry nodes. We have our curve with the animation, which is good. Now this curve, we can instance on it, on points, instance on points. And what we can instance is a string. If we use string to curves, we can type in anything, especially like numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and use those as our instances. If you look at that, this is going to be way slow. Make sure you have pick instance so that at least a random instance is picked for each point. The numbers will still fall down like that. Let's rotate these on, I think, is it the X 90 degrees? Another thing we want to do is come here, make sure that you have the pivot point set to midpoint, and alignment set to center, and this set to middle, so that these are in the center like that. Another thing you want to do is, if you look at these numbers, to make sure that all of them are in the same position, so I can use a set position, and use a command X so that all these are 0, and use that as the center, as the position, so that everything is reset to the center. And now that should be my instances. So we have, that. Now for the values, we can use our random value. I'll make sure this is float or integer. Connect that to the instance, and you can see now the numbers are a bit random. And I want this maximum number to be the number of integers you have. We have 10, so I'll use 10. That should randomize things. If we play back, we get that, but these digits are not moving, are not counting. So to make them count, we can use a time sequence or a time node and use the frame as the seed. Now if you play back, you can see those digits are now changing. We can turn this into a curve, maybe change the font. I'll use this digital, this font here. It looks nice. I can fill this curve just like that, so you can see the digits. Another thing you could do is use this spline factor as the scale, and that way the numbers become smaller by length. And I can use a float curve here and just make something interesting. So yeah, you can see the numbers now. From there we can join this. You can already see that we get something that looks interesting. We can now work on this grid city. That we can just use a plane. Let me make sure that I'm previewing this. Yeah, so we can have a plane like this, make it cover our matrix. Okay, we can come in here. I want to make a city block like that, simple city block like that. First thing I can do is subdivide this. Just look at this here. So if we subdivide this, we can make smaller subdivisions, but I want them to be random using the random value. Make sure this is Boolean, and I can use a separate geometry and separate by this. I want to separate faces. We have that, we have this. Now we can join this again, join geometry. So we have the same thing, basically the same thing. And on this we can subdivide again, and you can see what we have. Now, if we change the probability here, we get a different subdivision. I think I can do one here. With this, we can have this setup. You can have this setup in a repeat zone. So we bring in this geometry and this here and this here. That should have this in a repeat zone. That way we can continuously subdivide this as much as we want using these iterations. Yeah, you can make small subdivisions like that. Yeah, so we have something like that, and from there I can use an extrude faces, extrude these up, and just use a random value. I can even use this here, or I can just use combine XY and just random and use a random value, but that will just randomize each vertex instead of faces. So to make sure that I'm just randomizing the faces height, I can use something like the face area. Since this is linked to faces, this output is linked to faces, if I connect this to the ID, it will recognize that I'm trying to use a random value for the faces, unknown to vertices, and now the rest is just adding some materials and you have your matrix. So let's jump into the original file. So for the materials, I set up a building material that just simply used, this material just used a Fresnel here. It was a simple setup, it's basically using a wireframe node, just like that, and to get a nice grid onto the city. The materials are not so that complicated. So if you want to check out the full project file, links are going to be in the description. And